two problems. We're going to start with up here using the payback and accounting rate returns to make capital investment decisions, and then we'll just continue that down possibly both of these, sections 5 and 6. So, consider how Hunter Valley Snow Park Lodge could use capital budgeting to decide whether the $11 million Snow Park Lodge expansion would be a good investment. Assume Hunter Valley's managers developed the following estimates concerning the expansion. Number of additional skiers per day, 120. Average number of days per year the weather conditions allow skiing, 142 days. Useful life of the expansion, 7 years. Average cash spent by each skier per day, 241. Average variable cost of serving each skier per day, 83. Cost of the expansion, $11 million. Discount rate, 10%. Assume that Hunter Valley uses the straight-line depreciation method and expects the lodge expansion to have a residual value of $600,000 at the end of its 7-year life. Compute the average annual net cash inflow from the expansion. Compute the average annual operating income from the expansion. And so we'll start out with the average annual cash inflow. And so we'll just type out here that what we're looking at is the average cash spent by each skier per day, and we're going to multiply that by the additional skiers per day. We'll multiply that by the average days of skiing per year. And so let's wrap the text on all of these. Oops. Okay. And so when we come back up to this information, then we can pull that down. And so the average cash spent by a skier per day is 241. We're going to multiply that by the additional skiers per day, which they said was 121. Multiply that by the average skiable days per year of 142. And so we get 241 times 121 times 142 for a total average annual cash inflow of $4,140,862. So what's the average annual cash outflow? So we could say the average variable cost of serving each skier per day times the additional skiers per day times the average days of skiing per year. And we'll make all of these wrapped so that we can actually read them. And so the average variable cost was 83. Additional skiers, 121. Average days, 142. And then we can multiply these all together for 1,426,106. And so the average annual net cash inflow would be the difference of those two. For 2,714,756. So compute the average annual operating income is part 2. And so we need to start by looking at the total net cash inflows during the operating life of the expansion. And so we'll look at the average annual net cash inflow and multiply that by the operating life of the expansion. So we can pull this 2,714,756 down. The life was 7 years. So we multiply those together for 19,003,292. The total depreciation, so that's the cost minus the residual value, and the cost was 11 million. The residual value, is down here, 600,000. I need to put some commas in that because I can't, my eyes are terrible. So 10,400,000. And now that we have that, we can get to the average annual operating income by looking at the total net cash inflows during operation, or during operating life, minus the total depreciation during the operating life. That's going to give us total operating income. Then we're going to divide that by the expansion's operating life in years, and that's going to give us the average annual operating income from the expansion. So the total inflows, we calculated 19,003,292. Total depreciation, we calculated 10,400,000. And so we subtract those, we get operating income of 8,603,292. And this was a 7-year life. So we divide our operating income divided by the 7 years, and we get 229,042 average annual operating income from the expansion. And so we'll just continue this down, referring to that information, compute the payback for the expansion project, round to 1 decimal place. So I'm going to jump over to the next tab, and it looks a little bit funky, but that's okay. We'll zoom in a little bit. And so payback will be calculated as the amount invested divided by the expected annual net cash inflow. And so we can pull these numbers. Amount invested we know is 11 million, so I'll just type that. And then the expected annual net cash inflow we can pull from our previous tab. $2,714,756. I did not like that. What in the heck? Okay, I guess we're going to have to type it. I don't know what's happening. 2,714,756. And so let's do it down here. And it told us to round to, oops, sorry about that, to round to 1 decimal place. So I'll use the round function. 4.1 years, rounded. Okay, so we have our payback method. Now we'll move on to the next one using the ARR. So refer to the Hunter Valley previous information, calculate the ARR round to 2 decimal places. So let's come to this other Excel sheet. Zoom in. I'm going to change the view to normal. Okay, looks slightly better. So the average amount invested would be calculated as the amount invested plus the residual value divided by 2. And so the amount invested was 11 million. How many zeros do I have here? Short one. The residual value was 600,000. So we can say 11 million plus our 600,000, close parentheses, divided by 2, and we get 5,800,000. So our ARR is going to be the average annual operating income divided by the average amount invested. And our average annual operating income calculated somewhere down here, 1,229,042. And so, and our average amount invested, we just calculated as 5.8 million. So down here, we will take that average annual operating income, divide it by the 5,800,000. And so we get 21.19%.